we're back. So for try number 1, you should have a copy of the segment XY using the same steps. So start with drawing a line and then put a starting point that represents X, and you're going to put a tip of the compass on the original point X, and measure the other tip of the compass by putting the other tip of the compass on point Y, and without changing the angle of the compass, you're gonna draw an arc from your new point X. And then the intersection of that arc and your line will be the copy of point Y. Okay? Alright, so let's look at the next page. Example 2, copy an angle. How do we copy an angle? By just construction. So step 1, we're going to mark point X, okay, and use a straight edge to draw a ray with endpoint X. So now we're going to start with a point and draw a ray. And then, step 2, you're going to place the compass at point A. Okay, your tip of the compass should be on point A on your textbook. And then you're going to draw an arc that intersects both rays of angle A, so that we have an intersection point. And your arc doesn't have to be in a specific angle. It just has to make a intersection point. Okay, so don't make it too big or too small to make an easy arc. Okay, so make an obvious arc, and then you're going to label that intersection point B and C. And without changing the setting, place the compass point at X, your new point where the ray starts, and then you're going to draw the same arc. So then your arc will be the same, and your intersection point should be Y on your ray. And place the compass point at C, so your center is now on C, on the original angle. You're going to open the compass, you're going to adjust it so that the other tip meets point B. And then, using the same setting, you're going to start with point Y as a center, then draw an arc which will give you the intersection of Z that will be on the same distance away from both points X and Y, that is corresponding to the point B. So the constructed angle YXZ is a copy of angle A. And if you want to measure these angles and see if they're really the same, you can do it and copy how many times you want by using the exact same steps. You will get the same angle. So I dare you to try it if you do not see why this works, because you're using two arcs and an intersection point of those two arcs. It has to be the same distance from both points. So when are we using arcs? It's when we want to measure the distance between 2 points and copy that without using the straight edge as a ruler. Okay, it's just a straight edge. We're just going to use that to draw straight lines. Alright, now it's your turn. Try number 2. How can you construct a copy of angle B? Use the exact same steps and then draw a copy of angle B. Okay, so how do you do that? Do the same thing. First step, draw a ray. and then you're gonna mark a point, mark your end point, and then you're going to draw an arc that goes through your original angle. Using the same setting, you're gonna draw the same arc, and then mark the intersection point on your ray, another variable. And then you're going to adjust your compass again from your original angle between your two intersection points that you just drew an arc to make intersection points, right? And then using the same setting, you're gonna draw an arc from your new intersection point labeled, and then the second intersection point on your new arc, your new angle, is going to be your last intersection point that will give you a copy of your angle B. Okay? Alright, example 3. Construct a perpendicular bisector. How can you construct a perpendicular bisector of segment AB? By definition, what is a perpendicular bisector? Perpendicular bisector is a segment, is a line, segment, or ray, it could be either of them, that is perpendicular. What is perpendicular? It's a 90 degrees. So perpendicular to the segment, and divides the segment into two congruent segments. So it divides into two equal parts, but it also has to be perpendicular to the segment. So how do you construct a perpendicular bisector? You can also use straight edge and compass to construct the perpendicular bisector. So step 1, with a setting greater than half of AB, so you want to use a setting that is more than the midpoint of your segment, but of course it doesn't go past the other endpoint. It has to be in between the midpoint and the other endpoint. So if you're starting with point A, you can start with point B as a center. It just has to be a greater angle, a greater distance than the midpoint, the half of your segment. So with your eye, you can tell if it's going to be a little bit more than half or less than half, right? You don't have to know exactly where the midpoint is, but draw a setting greater with a setting greater than half the segment. You're going to place a compass point at A and draw arcs above and below segments A and B. It doesn't have to go through, but if you just want to draw an arc that goes through, that's fine. We're not going to use the intersection of that arc with the line, okay? You just need the arc big enough so that it has arcs that goes above and below the segment. And with the same setting, you're going to place the compass point at B, and you're going to draw two arcs above and below using the same setting. That means these intersection points are going to be the same distance away from points A and B. Does that make sense? Because you use the same setting on your compass. It's going to be the same distance away from points A and B. And if you label the points of the intersection of the arcs E and F, you can use a straight edge to draw a line EF. And the intersection point of this line and your original segment would be the midpoint, and the constructed line EF is the perpendicular bisector of your segment AB. Okay, so now it's your turn. Try number 3. Can you construct the perpendicular bisector of segment JK using the same steps? Construct it and come back when you are ready. Okay. Are you ready? Okay, so if you have a segment JK labeled, you're going to use your compass to draw two arcs. And remember, your setting has to be greater than half length of your segment. So draw two arcs above and below. From J and K, it needs to be the same setting. Okay? So then, this is your next step. I have these two arcs above and below the segment JK. And then you're going to use your straight edge to connect those two intersection points. And it has to be the perpendicular bisector if you drew it correctly. Okay? So by definition, this perpendicular bisector is perpendicular 90 degrees to your segment, and it divides your segment in half. Alright, let's look at example 4. Now we're going to construct an angle bisector. What is an angle bisector? An angle bisector is a ray. It has to be a ray that divides an angle into two congruent angles. Remember, your angle is formed by two rays. So from the same endpoint, you're gonna draw another ray that divides your angle in half. So how do you use a straight edge and compass to construct an angle bisector? These are the steps. Step 1, you're going to place a compass point at A, and then draw an arc intersecting both rays of angle A. And then you're going to label the points of intersection B and C. Okay, so you have to draw an arc that intersects both of them. And you're going to place a compass point at B, draw an arc in the interior of A. Okay, it has to be an arc inside your angle. With the same setting, you're going to place a compass point at C and draw the arc that intersects the arc that you just drew. Okay, your compass setting does not need to be the same as the distance from A to B in step 1, but it could be, but you can change it. Just make sure that your compass setting is not changed when you're drawing these two arcs inside your angle. Step 3. You're going to label the point of intersection of the two arcs D, and you can use a straight edge to draw a ray AD. And this, students, is the constructed ray AD, and it's the bisector, it's the angle bisector of angle A. Easy. So now it's your turn. Try number 4. How can you construct the angle bisector of angle G? See if you can construct it by yourself using the same steps. And come back when you're ready for the next. Okay, are you ready? So say you have this angle G. What do? You draw an arc from point G so that it intersects both of your rays. And then you will have two intersection points. Yeah? Yeah. And then you can draw the same arc, or you can move your arc setting. But from one intersection point, you're going to draw an arc inside your angle. And then from another intersection point, you're going to draw, with the same setting, draw another arc in the interior of your angle. Yeah? So this is your next step. And then this intersection of the two arcs that you just drew to your endpoint, your vertex of the angle, would give you the angle bisector. So draw another ray that bisects your angle. And this is how you draw the angle bisector. Okay? Just follow these simple steps. All right. Now, let's make an application of these construction methods. Example 5. We're going to use constructions to solve problems in real life. Let's look at this example. An artist wants to center align a new sculpture with a bay window in the museum lobby. He also wants to center align it with the entrance. What does center align mean? It needs to be in the center and it needs to be aligned. So it needs to be aligned with the door or aligned with the other object. Okay. He also wants to center align it with the entrance. Where should the sculpture be placed? So we want to place a new sculpture in this map. We already have several sculptures, right? But then this new sculpture has to be aligned and it needs to be in the center with a bay window in the museum lobby, the window here. And he wants to center align it with the entrance. So it needs to be in the center of both of them. So where does it meet? Right? So what is the construction that we need? So if the sculpture is center aligned with the bay window, it lies on the angle bisector of the bay window because the bay window has an angle here. Do you see that? So first, we want to draw an angle bisector. And that ray will give us one line where it could be placed, right? So it could be points on any ray if we only have that setting. But we also want to center align it with the entrance. So if it's center aligned with the entrance, it lies on the perpendicular bisector of the entrance because obviously the entrance is a flat surface and it's going to be a line or a line segment, right? So then we want to make a perpendicular bisector that is perpendicular to the entrance, but also bisects this entrance in half so that we know exactly where to put it in the center of the entrance. Yeah? So, easy. What you're trying to do is construct an angle bisector of the bay window, and then construct a perpendicular bisector on the entrance, and the intersection point of those two will be exactly where the new sculpture needs to be. Okay? So first, how do you draw the angle bisector? Follow these steps. You're gonna first draw the arc that intersects both rays of your angle. Okay, this is your first step. And then, second step, you're gonna draw two interior angles from your intersection points on the angle. This is your second step. And then you're gonna connect those 2 points, this intersection point between the two arcs and your vertex of the angle, to draw a straight line using your straight edge. And this is your first line. Okay? And then you're gonna now construct a perpendicular bisector of the museum entrance. How do you draw a perpendicular bisector? You're gonna draw two arcs above and below your museum entrance with the same setting on both ends. Okay? Then you know that these two intersection points are going to be the same distance between your two endpoints. And then drawing a line between these two intersection points will give you a perpendicular bisector. And if you extend that perpendicular bisector until it reaches your angle bisector, the point of intersection will give you the exact location where the new sculpture needs to be. So, how do we interpret this? The center of the sculpture should be placed at the point of intersection of the angle bisector of the bay window and a perpendicular bisector of the museum's entrance is shown above. Okay, so that is a practical way of using our constructions. Now it's your turn. Try number 5. Where should the sculpture be placed if it is to be center aligned with the museum entrance? In the center of the ticket sales desk. So if you look at this diagram above, ticket sales desk will be located on the right side of the museum. So what if we need to align it, center align it with the museum entrance and the center of ticket sales desk? Then what are you constructing? First, formulate a plan, and then construct, and then figure out the exact location. Pause the video and come back when you're ready for your answer. Okay, are you ready? So, what are you constructing here? You're constructing a perpendicular bisector from the museum entrance and a perpendicular bisector from the ticket sales. So how do you construct a perpendicular bisector? Draw 2 arcs that goes above and below your line, right, from the 2 endpoints, and then connect the intersection points to get a perpendicular bisector, and extend this so that you have the intersection point between the 2 perpendicular bisectors you construct. And that would be the exact location where it needs to be. Let's also explain that in words. So we're going to interpret and say the sculpture should be placed at the intersection of the perpendicular bisector of the museum entrance and the perpendicular bisector of the ticket sale desk as shown above or wherever you drove. Okay, that's it for the lesson. Let's summarize our lesson. We learned about constructions. What is a construction? A construction, by definition, is a geometric figure that can be made using only a straight edge and compass, where your straight edge is not used as a measuring ruler. Okay, it's used to straight edge is used to draw segments, lines, and rays. Compass is used to draw circles and arcs, and it's used to measure and copy length. So instead of your ruler, you're using compass to measure it. So these are diagrams to construct an angle bisector, just for a review. But you need to know how to construct all the constructions that we learned. How to copy a line segment, how to copy an angle, how to copy a perpendicular bisector, how to construct a perpendicular bisector, and how to construct an angle bisector. So using all these skills, we'll be able to construct and copy without using all the measurements and other tools. All right, that was lesson 1-2, basic constructions. If you have any other questions, please feel free to ask Ms. Kang in class. Otherwise, we'll continue with the lesson in the next video. Bye.